right, pre-calc class, we're on to section 6.2. So we're going to do some more inverse trig problems, but I'm going to try and make them make sense as best possible. So again, this is all based off the unit circle. If I translate this problem from your section, this says to me, what angle has cosine 1/2? Tell me the y value. Or for the angle that has x value 1/2, tell me the y value. And again, if we know the x value is positive, we know we're in the first quadrant, so the y value must be positive also. And we know that 1/2 is basically married to √3/2. And we're done. Right? You know those two go together. If that's the x value, the y value is √3/2. This one's a little more interesting. First of all, it's negative, so that tells me I'm in the second quadrant. So that tells me I'm over here, right? Where's the x value? Negative √3/2. So we know the coordinates negative √3/2, positive 1/2, and it's asking what's the tangent. The tangent would be the y over the x, and you can ignore the denominators because they cancel. So the answer is negative 1 over √3, which we have to rationalize, and we'd get negative √3/3 as our answer to that problem. Tangent's y over x. All right, this one translates into, for the angle that has x value 1/2, what's the secant? Well, if the cosine's 1/2, the secant's the reciprocal, so that's just 2. All right, and this one's saying for the angle that has y value negative 1/2, so I know my y value is negative 1/2, what's the cotangent? Well, again, 1/2 goes with √3/2, and if I know I'm doing inverse sine, then I know I'm in this quadrant here, because inverse sine takes these two quadrants. So I know my x value is positive. So I know I have a positive √3/2, 1/2, cotangent x over y, so I get negative √3 as my answer. Okay. Number 16, it's saying for the angle that has tangent √3, which we can say is √3/1, what is the secant? Well, if my tangent's √3/1, then I know my y value is √3, and my x value is 1. So either I can figure out where this is on the unit circle, or I could do Pythagorean theorem to find the r value. Let's just look at this. If the y value is √3 and the x value is 1, and again the denominators cancel, I know I'm up here at pi over 3. So if it wants to know the secant would be the x value flipped, which would just simply be 2. That's the answer for that one. All right, just looking at the unit circle, it is right there. All right. Here's the first time we've had a negative angle for a while. So a negative 7 pi over 6. So first we figure out where 7 pi over 6 is. And then a negative angle goes straight up. This is the angle for negative 7 pi over 6. So I know my coordinates are negative √3/2, comma 1/2. And then they wanted to know the y value. So first of all, I have 1/2. So this question is asking what angle has y value 1/2? Well, I know that this is in the wrong quadrant for inverse sine. Inverse sine has to come out of the first two, so I'm asking what angle has y value 1/2, and that's pi over 6. So my answer for this question is pi over 6. And that's it. All right. Now it gets some more interesting. 1/3 is not a coordinate on my unit circle. So I'm going to have to use Pythagorean theorem on this one to figure out my values. Sine stands for y over r. So tangent stands for y over x. So I need to find the x value. And Pythagorean theorem says x squared plus y squared equals r squared, or the equation of a circle is x squared plus y squared equals r squared. So I don't know my x squared. I know my y squared is 1 squared, which is 1, and I know r squared is 3 squared, which is 9. So if I solve for x squared, I get 8. Square root of 8 is 2 root 2. So I know my x value is 2 root 2. So if I'm solving for tangent, tangent's y over x, so that would be 1 over 2 root 2, which I can't leave that way. So I multiply by root 2 over root 2, and I get root 2 over 2 times 2, which is 4. And that is the answer for this problem. Since it wasn't on the unit circle, I had to use quadratic formula. All right, same thing here, quadratic formula, but I want to be smart about this and realize that this was really -1 over root 3 before it was fixed. So cosine stands for x over r, and cotangent is asking for x over y. So I have the x value, but I need to find the y value. So again, Pythagorean theorem, I know x squared plus y squared is r squared. -1 squared is 1, plus y squared equals square root of 3 squared, which is 3. So following that, I get y squared is 2, and I get y is the square root of 2. So my cotangent would be the x, which is -1, over the y, which was a root 2, and to fix that, I get negative root 2 over 2 as the cotangent. All right. Last but not least, we had some problems where you wanted to use the calculator, but I don't have a cosecant button on my calculator. So what we had to realize is that if the cosecant is 5, then we know that that's the reciprocal of sine. So I know that my sine is 1/5. And then making sure my calculator is in radian mode, I would just press second sine 1/5. And I get, I think it said to give me 2 decimals, so my answer is 0.20. I'll probably ask for like 4 decimals, so 0.2014, round the 4th decimal. That's what I would write as the answer. Now, this one's trickier. Cotangent doesn't quite relate as nicely to tangent. If you remember when we graphed tangent, tangent went over the x-axis. Do you remember how we were graphing tan and tan goes like this? So tangent is an odd function, and that's why we talk about inverse tan being just like inverse sine. Inverse tan goes from -pi/2 to pi/2. But cotangent, if you recall, when we were graphing cotangent, cotangent went from 0 to pi. So the inverse trig is going to be just like cosine and go from 0 to pi. So what I really need to do is figure out how this one relates to cosine, because inverse cosine also goes from 0 to pi. So I know the cotangent stands for x over y. So I know my y value is 1, and I'm going to have to use Pythagorean theorem to figure out my r. So I get 8.1 squared plus 1 squared equals r squared. So let's just do that. 8.1 squared plus 1 squared is 66.61. The square root of that is 8.16. So I know that my r value is 8.16. And I can't write because my paper's moving in this corner. 8.16. So now I can set this up as if the cotangent was -8.1, I know that my cosine was x over r, or -8.1 over 8.16. And I can push those buttons in my calculator. Inverse cosine of -8.1 over 8.16. And I get 3.2, which is the right answer. That's a lot of work for that one. So this one was 3.02, excuse me. So again, because cotangent is an even function like cosine, as opposed to an odd function like sine, I could not take cotangent and go back to knowing the tangent's -8.1, 1 over -8.1, because that would give me an answer in the wrong quadrant. Whereas I know that cotangent, if it's negative, should be coming out of this quadrant. And that's why I had to figure out inverse cosine to do that one correctly. Hope that made sense. If not, rewind and watch it again. Thanks, and hope to see you before spring break. Maybe.